no other than the EMEA sustainability lead for one of our great partners, Amazon Web Services. So I'm going to say he's a veteran who is a technology leader, and he's a frequent speaker, so you're going to love what he has to say, an advocate of cloud technology, and an enabler in sustainability. In his role as AWS Sustainability Leader for EMEA, Mr. Thomas Blood, who's coming up next, and his team work for customers to accelerate reaching their sustainability goals and ambitions. So I know we're behind schedule. Put your hands together. It's going to be great to have his insight here. Mr. Thomas Blood.
Good afternoon, everyone. First, I want to say I'm thankful, I'm honored to be here. Sharaftu ana nakun ma'akum hadhi al-yawm. And I'm really excited about this topic. I want to echo what Nuruddin said earlier, that we can't do this alone, we have to do it together. And so we think of this very holistically. Maybe if I get a slide. Okay, there's a build. So we think of this very holistically. So AWS, Amazon Web Services, of course, is part of the larger Amazon. And so I wanted to start with the Amazon story very quickly. We co-created the Climate Pledge in 2019 with the ambition to invite customers and companies to join us to reach the Paris Agreement in 2040, 10 years early. I have some other things that I'll talk about in just a second. I'm going to go fairly quickly. I want to help catch up the time. We also have a pledge for Amazon Web Services to be water positive. Water positive means we want to return more water to the environment, to the local communities than we consume. We do this by being very careful in terms of the consumption patterns in our data centers. We use some very creative cooling techniques. We use recycled water or rainwater collection when there is rainwater. We have recharge programs where we actually put water back into the ecosystem. So for instance, if you cool a data center, you can use that water to do irrigation in the fields afterwards. And then finally, we also invest in community projects to create water sources or to prevent water from being wasted. So for instance, in Cape Town in South Africa, we partnered with an organization, I can't remember right now, but with an organization that basically helped remove a foreign species of plant that was consuming huge amounts of water, millions of liters of water per year. So we just helped remove that and create that water back to the community. Amazon is the largest buyer of renewable energy in the world. We have 470 projects to date with 26 gigawatt of capacity. And the purpose of this is to make sure that we reach our goal of being carbon neutral, energy neutral with renewable energy by 2030, but we're on track to do that by 2025, 5 years ahead of our original plan. So that means all of our data centers by 2025 will be running on renewable energy. So any workloads that are running there will be essentially running at maybe 4% carbon because of the embodied carbon in the equipment and in the servers and in the data centers, but not based on energy. We take this very seriously. Oh, what's going on here? Here we go. We take this very seriously. We think, again, holistically about this. So when you think about a data center, of course, is a very large structure. So we have requirements now going forward that all new data centers use carbon-reduced cement. We've also invested in companies with a Climate Pledge Fund to reduce carbon. So for instance, there's a company called Carbon Cure, which basically captures the CO2 that's emitted during the production of cement and then injects that CO2 back into the cement when it's poured so that it's embodied in the building. We do the same thing. We have an investment around low carbon steel for those facilities. Again, trying to take the carbon out of the entire process end to end. We also, as Amazon, invest in nature-based solutions. Again, as Nuruddin said, offsets are not a great solution. They are a bridge. But what we can do instead is we can actually directly invest to reforest, to create mangroves, to invest in grasslands, as Andy said a minute ago. So we have investment funds to do that because we want to make sure that the mix of what we're doing is all inclusive, including nature. So my team in AWS and Amazon Web Services, we work with customers like yourselves, with our partners, to see what else can we do. How can we accelerate the transformation to a sustainable future? How can we do what Nuruddin talked about, that we are responsible for the future of our children and grandchildren? How can we have our grandchildren thrive? A quick story. When I was a kid, I used to go out into the woods, and there was this amazing humming in the air, buzzing of insects. It was magnificent. It was beautiful. I would walk around, and you could smell the herbs in the grass, and it was just wonderful. I have grandkids. My grandkids cannot hear the humming and the buzzing of those insects anymore because they're not there anymore. So I want to help create a world where my grandkids can have that experience, where they can smell those herbs, they can walk around, they can feel the wind and the sun in their face, and just be joyful in the world. And we can thrive. So to this end, we want to work with our customers and our partners to really accelerate, as Nuruddin has said, this transformation. And it's a dual transformation. It's a digital transformation and a sustainable transformation. We've come up with something we call the Future Fit Framework. It has 4 levels, not levels of levels of excellence, but levels of complexity or levels of investment. Level 1 is about green IT. It's about making IT as efficient and as sustainable as possible. Level 2 is about removing all the waste that we have put into our processes over the last 50 years, 100 years, where we can take out inefficient processes in water and energy, in production and in manufacturing. Level 3 is we need to invent the things that do not exist. What are the things that we need in the world to be able to have the sustainable future that we want? What are those things? That's an opportunity. We can invent those things. Gartner believes that the things that we need to invent by 2050, 50% of them do not exist yet. That's an opportunity for all of us to lean in and create those things and invent them. And level 4 are thinking about how can we transform our business end to end? How can we put nature and the world and a thriving economy and a thriving society into the center of what we're doing? That's a transformation end to end. So I'll give you some examples for each one of them. Level 1, as I said, is removing the inefficiencies from IT. And it's always a trade-off, right? We have to think about what are we trying to accomplish from a business perspective, and what are the costs, both commercial costs, financial costs, but also in terms of sustainability. So one way to think about this is, again, if you're migrating things into the cloud, you're benefiting from running on renewable energy. You're benefiting from systems and the data center and the racks and the technology that is as efficient as we can possibly make it. For instance, Amazon Web Services, we've created our own silicon. We have our own chips. Graviton 3 is 60% more efficient than a comparable instance type. We just announced at reInvent last week for machine learning algorithms, for generative AI purposes, for large language models, new silicon that is 50% more efficient per watt. So you can actually double your performance using these new technologies that we constantly evolve and we're constantly inventing and working on. So level 2, as I said, is about taking the slack out of the system. And one really, really good example of this is we worked with Coca-Cola bottling company, İçecek plant in Turkey. And they came to us initially and they said, hey, can you help us take the cost, reduce the cost of this bottling plant? So they built a digital twin of the plant in 8 weeks. And then 8 weeks later, by optimizing all the settings they had in the plant and implementing those optimal settings, they reduced their energy consumption by 20%. And importantly, in Turkey, they reduced their water consumption by 9%. So optimization is actually a very achievable thing for all of us to do. Same with HVAC. I picked HVAC because we're here, right? HVAC is one of those areas where there's a lot of inefficiency in our buildings and our systems. We can do much, much, much better. So if we apply technology together with Atos and we look at the opportunities to reduce the energy inefficiencies, to set the right settings when the climate is changing, weather is changing, Well, reducing your setting by 1 degree, for instance, can have a magnificent impact on your cost and also on the environment. So I'm always looking for that intersection between reducing cost and reducing sustainability impact. Our CTO for Amazon, Werner Vogel, says cost is a great proxy for sustainability. So let's look for those opportunities to take the cost out and reduce the carbon footprint and improve water efficiency and improve soil health and improve all the things we've heard about so far today. Same again with water. There's, I believe it's 70% of the water in the world that is running through water systems is wasted in leaks. Can you believe that? Water is just leaking out of the pipes and out of the seams because the infrastructure is so old. You know, we built these systems 100 years ago. We weren't very careful. We didn't, and plus corrosion and aging of these systems. So what can we do to find the leaks as quickly as possible and to fix the worst leaks to reduce our water wastage? Again, this is a very relatively easy thing to do with a big impact. So level 3 is around innovation, as I said. One way to innovate, again, as Nourdine talked about, is data. What do we do with data? And I think all of you have data sets that actually might be useful to other people, the way Andy described. And if we can we aggregate the data not just for ourselves and for our own analysis, but can we share that data more broadly and put it into a system? We have something called the Amazon Sustainability Data Initiative, where we host data from companies and organizations that want to make that data available to academic research and to other companies to build solutions upon. Again, there's data in the system around soil health in Africa, around mangrove coverage. We have satellite imagery. We have huge data sets that people can use. And again, you're invited to think about, is there anything there that you want to contribute to that kind of a thing? One of the companies I work with is Arup. You may know Arup, construction company. They do all the planning and the assessment up front. They did this great piece of work last year, 2 years ago, in Singapore to use geospatial data analysis to understand where are the heat islands in cities, and then to think about how do you mitigate those heat islands. And as the temperature rises, especially in warmer parts of the world, this becomes critically important because we've seen that the impact of heat in cities has a direct impact on actual lives. People die because it's too hot. So what can we do? We can plant trees, we can think about the convection through the cities, we can build smarter, but we have to understand first where the problem areas are. So Arup built a solution for that with us. And I want to continue to build those kinds of solutions. Again, if you're interested in biodiversity, in urban planning, in transportation, whatever it may be, we want to work with you to find those solutions to help solve these hard problems. Here's another example, a company called CropX that's looking at how do you optimize precision agriculture with water. We waste a lot of water in agriculture because we're not careful with it. We've treated water in many parts of the world, especially in the US, where I spent 30 years, as a free resource. It's an unlimited resource, and we just waste it. I know that's not the case here, but in many parts of the world, we're not careful with it. So what can we do? Again, using technology, using sensors, using data analysis, we can look for those opportunities and create precision agricultural technologies that bring the right amount of water to the plant where it's needed with the right nutrients. And here's one of my favorite stories from last year. Who has been to the Natural History Museum in London? Is that a magnificent place or what? It is one of my favorite places. If you have never been to the Natural History Museum in London, next time you're in London, please go check it out. It's fantastic. And so they came to us and they said, we want to teach children in the city about urban nature. We want to get kids excited about nature who maybe are not in the woods, kids who've maybe never been in the woods. So how do we do that? Well, we have parks, right? We have trees and we have plants in the city. So they wanted to create a park, a learning environment to get children excited about science and about nature and to create the next generation of citizen scientists. So we worked with them on this. They're going to launch that next year, hopefully in the summer or so, this program. But in working with them, we learned that Natural History Museum has 350 scientists. I had no idea. And these 350 scientists are actually predominantly experts on biodiversity, Andy. And those scientists really wanted to understand what they have in the museum. The museum has 400 years of a collection of insects and seeds and plant parts and soil samples from all over England, and it's buried in the vault. It's buried in the basement somewhere. 80 million artifacts, 400 years of history. So we worked with them to use machine learning algorithms to help the scientists identify the species that they have much more quickly and tag them to a map and create a complete map of Britain. We're working on it, it's not done yet, but a complete map of the UK to identify where species used to live, what kind of specific bees happen to be in a particular area. When you do that, you can apply, again, this time series analysis. You can understand what happened historically, and then if you want to build a bridge or a highway or a canal or something, you can now predict and anticipate what would happen to that environment based on the historical data. So I'm super excited about these kinds of efforts, and I really hope that we can all work together and continue to do what Nuruddin said, pull together as all of us to solve these very hard problems. Thank you very much.